Arduinos and other microcontrollers are popping up everywhere. They're amazing and powerful devices, but are they really suited to industrial applications? In this video, we will compare automating a simple process using an Arduino microcontroller versus the Automation Direct Bricks PLC. Our conclusion is that while the microcontroller can do the job, it takes additional hardware and more programming effort than a purpose-built industrial controller, such as the bricks. Here is our basic flow loop installation. A Rosemount 3051 flow meter measures water flowing through the pipe, and the flow rate is governed by this Fisher control valve. The third element of the loop is a controller that reads the flow meter and tells the valve how much to open to achieve the desired set point. PI control can do the job nicely. This is basic closed-loop control, and examples are everywhere in the real world. So can an Arduino Uno, which can be bought for about $25, handle this basic function? Yes, it has the capability, but it needs some help. An Arduino does not handle the 4 to 20 milliamp current loops common to industrial field devices, and which our flow meter and control valve both use. The Arduino's analog input is a voltage loop, but the current loop can be converted, so that part is easy. The output is tougher since the analog output is via 500 Hz pulse width modulation. Converting that requires a sophisticated circuit, but it works. All the software to communicate with the devices and perform the PI calculations has to be written from scratch, but an experienced C programmer shouldn't have too much trouble. We added a tiny display to see what's happening, along with potentiometers to control the set point, plus the P and I factors. There are no units outside a percentage of scale, but they do provide control. So, does it work? Obviously it took a lot of effort, but the answer is yes. The Arduino can control the loop, and it can respond to changing conditions to maintain the set point. When changing the P and I values, it behaves like a typical controller. It's a complex undertaking, but if you're persistent, it can be made to work. Why you would is a different question. Now, let's compare that to a basic PLC, in this case an Automation Direct Bricks. Connecting the field devices is easy because a 4 to 20 milliamp current loop is just one of the selectable communication protocols built in. The only programming necessary is a simple ladder logic routine written using the Do More Designer software downloaded from the website. The PLC communicates with a laptop using an Ethernet cable for programming and operation. When the loop is running, the Do More software provides the interface to see what's happening and to make changes to settings. But if the computer is disconnected, the bricks will continue to control the loop using the most recent settings. For new users, there are many resources and videos available online to show how basic programming is done. The Arduino can work with industrial devices, provided there is enough technical support, but for the bricks, it's exactly what they're made for.